Hello, everyone, and thank you so much for coming to my talk today. I'll start by introducing myself. My name is Thanos Gladaris. I am a student collaborator on NASA's Perseverance rover, which is currently exploring Mars. And I'm a PhD student in planetary science at Purdue University, which is in the state of Indiana in America. Today, I'll be talking about one of the biggest questions in science right now. Is there life on Mars? Searching for life with NASA's Mars rover. So, the short answer to that question is we're not sure. But in this talk, I'll tell you, why do Mars scientists think there might be life there? How is NASA searching for that life right now? And maybe most importantly, when are we going to know for sure? But first, we need to start with the basics. Here's a diagram of the solar system. It's not to scale. As you can see, Mars is the fourth planet from the sun, meaning that it's further from the sun's heat and therefore colder than Earth is. Mars is about half the size of Earth, so quite a lot smaller, but definitely bigger than the moon, for instance. And here's a map of Mars's surface. There's no bodies of water. It's a cold planet with a landscape that's dominated by rocks, sand, and dust. So it's a very inhospitable place. And today, Mars has like a cold desert climate, like you'd find in Antarctica. A lot of the planet is covered in sand dunes. So here's a black sand dune that was found by the Curiosity rover in Gale Crater, which looks super cool. And here's some real audio that was recorded from the surface of Mars. I'm not sure you'll be able to hear it, but you can find it on YouTube. Definitely look it up. And what you can hear is the wind going by, and it was recorded by one of Perseverance's microphones. So Mars does have an atmosphere, but it's just incredibly thin. It's just 1% as thick as Earth's atmosphere. No matter where you look on Mars, you find a thick layer of dust. This dust is made from iron oxide, which is commonly known as rust. And so that's the reason that Mars is known as the red planet. Even though, in my opinion, it's more of an orange color or like a beige. When the wind picks up fast enough, it can loft that dust in the air in vortexes. And we often see these, they're called dust devils. They're kind of like mini tornadoes. And they're the white streaks that snake across the landscape in this video from Perseverance. They're really common. I think if you were standing anywhere on Mars during the windy summer and looked out across the horizon, you'd probably see at least one of these dust devils at any given time. So there's definitely an atmosphere. I think all this shows that Mars today is inhospitable for life. It's too cold, it's too dry, and there's too much radiation, even for simple life forms to live on its surface. Even a microbe or a fungus would really struggle to survive on Mars today. However, we have strong evidence that Mars was not always this way. Here's an artist's impression of what scientists think Mars looked like 3.5 billion years ago. Back then, Mars was covered in rivers, lakes, seas, and maybe even an ocean in its northern hemisphere. Given that was so long ago, how could we possibly know that this was the case? Well, the first evidence for this was found when we sent the first robotic spacecraft to Mars in the 1970s. They sent back photos of ancient landscapes that are covered in dried up river channels. When you look at this image, I don't think you need to be a scientist to recognize that water clearly flowed across this landscape. So this tells us that in the distant past, really far back, Mars had abundant rivers, which must have been fed either by rainfall or melting ice. But where did all that water go? Well, while liquid water isn't stable on the surface of Mars today, solid water, also known as ice, is common, especially at the North and South poles. So just like Earth, Mars has an ice cap at its North and South poles. And here's a picture of the northern ice cap. So there's plenty of water, it's just in frozen form. We now are regularly exploring the surface of Mars with robotic spacecraft. No humans yet, but robots were doing it. And we can look at the rocks on the ground to tell us about past conditions. So here's an image of a pebbly stream bed deposit with pebbles that have become rounded by the action of water, just like you'd find in a stream bed on Earth. And so this confirms that water was definitely flowing across Mars's surface. We have also found evidence of ancient lakes. Specifically, we found thick deposits of mud, and mud only forms in standing bodies of water. The type of mud tells us that the water was warm, it was not too acidic, and it was long-lasting, long-lived water body. So in other words, ideal for life. So all this begs the question, if Mars was so Earth-like in the past, did it have life? Well, this diagram shows the 4 ingredients scientists believe are needed for life. We know Mars had water, we've got that one checked, and we know there was energy in the form of sunlight and volcanic heat. We've also measured the chemistry of the rocks and confirmed that they have the 6 essential elements needed for life. That's carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. But the biggest unknown is that triangle in the middle is time, because we know there was lakes and seas, but how long did they last? Billions of years? Or just a few thousand years? Let's say life did emerge on Mars, as many scientists think. Well, what should we look for? Should we be looking for fossil plants or animals, like the pictures on the left? Or should we be looking for simpler life, like fossil microbes? Well, for most of Earth's history, the most sophisticated, complex life forms have been microscopic. They've been microbes. It's only in the last 15% of Earth's history, which is recent relative to the history of our planet, that life became complex enough to allow for plants and animals. So given that Mars was only habitable at the beginning of its history, in this blue column here, that tells us we shouldn't be searching for little green men or plants or animals. Probably the only complexity life could have evolved in that short time would be microbial. However, there's a problem here. Microbes are tiny, literally microscopic. So to really search for fossil Martian life, you'd need to study Mars rocks with the very powerful microscopes that we have here on Earth. That's why one of the goals of the Perseverance rover mission that I work on is to collect rock samples that a future mission will bring back to Earth. So, summarize, to find life on Mars, NASA is following these steps. First, it's exploring the surface of Mars with robots and to try and find the environments where life could have once flourished, where fossils could be preserved. Step 2 is to collect rock samples from those places and send those rocks back to Earth. And the final step is to study these rocks in high-tech laboratories so that we can be confident that what we're seeing is real. Because the worst thing that could happen would be for NASA to announce they found life and tell the whole world about it, only for later analysis to prove that they were wrong. That's why we need to be really, really sure. and why we need to bring those rocks back to Earth. Only two countries have successfully landed rovers on the surface of Mars. America, which has done this 5 times since 1997, and China, which landed its first rover called Zhurong in 2021. And here is an image showing the test models for 3 of America's rovers side by side, and also the years that they launch. You can see that since the late 1990s, they've been getting bigger and bigger, and they're now enormous. Shown here are the 2 largest American rovers, Curiosity, which landed in 2012, and Perseverance, that's the one I work on, which landed in 2021, so only 3 years ago. And they're similar in many ways. Both are around the size of a large car, but Perseverance is the first to sample rocks to be returned to Earth. Both of these rovers are still active on Mars today, even Curiosity, which is well over its expected lifespan. Perseverance is a marvel of engineering. I think anyone can appreciate this, no matter what background, because it has so much cool gadgets. So on its head, also known as the mast, it has a laser and a telescope to study the chemistry of rocks. And it also has its eyes are there. They're the 2 zoom cameras, which is the instrument I work on. There's also weather sensors on its neck, which monitor the wind speed and the temperature, things like that. It has a large arm, and on the arm are instruments, science instruments that investigate the rock very detailed, close up, including an X-ray beam and an ultraviolet laser, all to try and characterize, are there signs of life in this rock? Could this be a rock where life could have survived in? And in the belly of the rover, there's ground penetrating radar. That's the first time we've ever brought radar on a Mars mission, and we use it to map out layers in the subsurface as we drive along, which is just what archaeologists do when they first arrive at, say, a Roman villa or an archaeological site. And lastly, maybe most excitingly, we have a helicopter, the first helicopter ever sent to another planet. It's called Ingenuity, and I'll show you more later. So NASA recorded real video of the landing, and it filmed its own landing, and you can find this full video on YouTube, and I really, really encourage you to, because it's extremely cool. Here's some snippets from it. Here it shows a view looking up at the sky of Mars while it was landing, and you can see the parachute shoot out of the spacecraft and inflate, which is so cool. It's a giant parachute that was needed to slow us down so we could land. And the red and white patterns on the parachute, those stripes, they look very specific. They're actually their binary code for the motto of the Jet Propulsion Laboratory, which is the university which built the rover. So that's just a cool Easter egg. And here's one of the final moments of the video, right before the touchdown, which was on February 18th, 2021. And what you can see is huge clouds of dust being kicked up by the force of the landing engines. And that's the rover there. We're looking down at the surface just before landing. You see the rocks. And the rover is dangling on cables because it's being slowly lowered to the ground as gently as possible. It's an amazing system. Another NASA spacecraft, which was orbiting the planet at the same time, it managed to snap this photo of the rover landing. If you look in the zoomed in view, you can see the parachute and the rover dangling below, slowing the descent. That yellow star there shows the landing site that we ended up landing at. So where did we land and why? This turns out to be a huge question for a mission as important as this, because there's an entire planet to choose from. Where do you land? You've only got one shot. So we wanted to pick a landing site with the highest chance of preserving fossil life to guarantee mission success as much as possible, while also balancing safety concerns. We didn't want to land on top of a giant boulder because that could have crashed and the rover could have been destroyed before it ever started its mission. So the science team spent years debating this decision, and they eventually chose a place called Jezero Crater. This is an impact crater that's 28 miles wide, and orbital images show it was once filled with water. And we chose it because microbes could have thrived in that lake. Here's the other Jezero. My best friend, who also works on the rover mission, he named his kitten after the crater Jezero. So there's two Jezeros out there. I'm not sure which one's my favorite. It's difficult to choose. She's amazing. She's the best. She's only like 2 years old. So we landed, and shortly after landing, Perseverance gave birth. You can see this smaller spacecraft kind of coming out of the underbelly of the rover. And there it is, plopped safely on the ground. What was that? Well, it was the helicopter. And this is a real selfie of these two spacecraft, the rover on the right, Perseverance, and the little helicopter on the left, Ingenuity. Ingenuity was the first helicopter ever sent to another planet. And here's a real video of it spinning up its blades, preparing for flight. And there she goes. So Ingenuity achieved the first ever powered flight on another planet, which proved that it is possible to fly on Mars, even despite its thin atmosphere. It was just a technology demonstration, and it was designed to fly just 5 times, but it ended up flying 72 times before, unfortunately, it crashed into a sand dune at the end of last year and its mission ended. But it was a huge success and proved beyond doubt this was possible. But why do that? Why bring a helicopter with us? Not simply to prove it for the sake of proving it, but we wanted to use it to scout out terrain. So it would fly ahead of the rover and map out where the rocks and the sand dunes are, which helped us plan where our drive would be for the landscape, which helped speed up the rover's science. And it could also visit places we could never drive to. So things like cliffs and giant sand dunes that the rover couldn't drive across, the helicopter just flew over. And so we used it to investigate rocks that were well outside of the rover's reach. Let's explore the red planet of Perseverance. What did we find? So we landed right next to an ancient river delta that was formed at the shores of an ancient lake. Now, all this water is dried up now, so we're seeing the kind of ancient remnant of an ancient lake and river system. Well, at least that's the hypothesis. That is what we thought before landing. Well, did we actually confirm that? And that yellow star again, that shows right where we landed near the base of that delta. And here's some examples of river deltas on Earth at the top. And then at the bottom is the one in Jezero Crater that we explored. And why go here? Why was this so important? Well, a river delta. You've got a river that's bringing in nutrients that life could eat. And you've got a lake. And the delta must have formed over a significant period of time to build out that sediment. And so all those factors are ideal for life. And we chose this landing site to explore it. Here's an orbital map that shows the path we've traveled across Mars in the last 3 years. It's been something like 20 kilometers distance. So we first landed on the crater floor, and we found lava flows there, which was a surprise and good for the geologists. We then drove up to the base of the delta, where we found an ancient lake bed deposit. We then drove over the top of the delta, and you see those little icons, those blue icons on the left. You can see where the helicopter and the rover are. Helicopter is stuck in a sand dune and dead. But the rover is, as you can see, it's just a few days away from entering into the main river channel itself. And in fact, I think literally right now, we commanded the rover to drive into the river channel. And we're really excited to see what we'll find there. At the base of the delta, we found sediments that we think were deposited in a salty ancient lake bed. And here's an orbital view of those rocks. And we found one of the most exciting findings of the mission when we investigated those rocks up close. You can see this very layered rock right underneath the rover wheel here. And what we found was that these rocks are rich in carbon and the kind of carbon that life would use. This could actually be fossilized microbes. But with perseverance, we can't be sure. And as I said, we want to be really, really sure. So we sampled this rock. And it's one of the most exciting science samples that we plan to bring back to Earth for closer study. When we drove over the top of the delta, that's the next thing that we did, we found rocks that were full of pebbles and boulders. And this told us that they were deposited by a raging river. And so far with perseverance, we can say we found a shallow, salty lake fed by a river. And here's an artist's impression of what that might have looked like 3.5 billion years ago. Life could have flourished here. We've collected 24 diverse rock samples, different kinds of rock, different settings, to maximize the chance that one of them contains fossilized life. And our next step is to bring them back to Earth. How are we going to do that? Well, we're going to do it with robots again. If everything goes to plan, Perseverance's samples could be back on Earth around 2032. We hope to land a lander on the surface near the rover. The rover would drive up to the lander, give the lander the samples it's collected, the very valuable samples, and then it has its own rocket, which will blast off from the surface of Mars, enter Mars orbit, and then head back to Earth, which will be the first time that a spacecraft has ever gone from the surface of Mars to its orbit. I mean, it would be amazing. A very complex and very expensive mission. So 2032 would be the time, the earliest time where we'll know, you, the wider public, if life evolved on Mars. So we're all excited and working towards that. Yeah. So I want to wrap up by saying thank you to the team that's made Perseverance so successful. It's scientists, engineers, administrators, and politicians. They all work to make this happen. We're making amazing discoveries on the surface of Mars right now. I love what we do. And here is a photo from the science team meeting we had last year. So once a year, all the scientists, from junior scientists all the way to senior scientists, every stage in their career, we all converge on a place. And last year it was in Paris, which was amazing. So I basically had a free holiday to Paris for a week, and we all met up and we were at like the Paris Natural History Museum. It was amazing. And I'm in that photo somewhere, the little yellow arrow, that's me. So lots of people, hundreds of people, of all ages and all genders. So yeah, that was amazing connecting with everyone. Our next meeting will be in California in July. So, do you want to be a planetary scientist? Come join us. It's an amazing field of science. We don't just study Mars. we study the moon, we study asteroids and comets, we study Jupiter and Saturn and their rings, and we study alien life. It's a very diverse field of science, and it's a very exciting and growing field of science. And I think if you join us, you could be part of something really cool. But you need three things. Um, Here are the three things that you need to become a planetary scientist. You can't skip any of these steps. So firstly, reluctantly, you need a good maths grade. It's not enough to get C in maths. You need at least, I'd say, a B or an A, ideally an A or an A star in maths. Although I will say, you don't have to enjoy it. Maths was never my strong suit. I never loved maths. I always struggled with maths. It was a subject I never enjoyed. But I realized that in order to do what my dream job was, which is what I do now, I needed a passable maths degree, a maths grade. So I put in a lot of work, a lot of hard effort. Even though I didn't love it, I managed to push myself and I got that A in maths. And that A in maths will unlock so many opportunities to you. Don't have to enjoy it. And here I am doing this dream job, and I don't use maths that much in my field as a geologist. So if you want to, you can totally specialize in an area of planetary science which doesn't use much maths. I don't use it very often at all. And yeah, I get to work for NASA, so it's amazing. The second thing you need is you need a university degree in a STEM subject. What does STEM mean? It means science, technology, engineering, maths. That covers a lot of things, right? A huge range of degrees, all of science and beyond. I mean, there are people on the rover team that are from a mathematics background, from a physics background, astronomy background, chemistry background. I'm a geologist, I'm a geology background, and there's even biologists on the team, people who specialize in thinking about alien life. So it's very broad. Whatever subject of science you're interested in, you can find it in planetary science. I'd also recommend learning to code. You don't have to be a master programmer. You just need to be, I think it's a really good skill. It will be really useful in your science career, and it's something that will just give you a leg up. If you can code, it unlocks a lot as well. And then finally, most importantly, I think you need to be enthusiastic. If you care about this, if you find this interesting, look up news articles, look up blogs. There are public forums and subreddits, Instagram pages. I'll tell you all about planets. Keep up to date with the latest news. Show that you care, because that last thing will help you stand out from everyone else. There's plenty of people who have science degrees and good grades in science degrees, but if you truly care, you will shine in an interview and you're much more likely to get that job. So that's all I have to say. Here's the whole team, including all the engineers, not just the scientists. So you can see there's hundreds and hundreds of them. And that will wrap it up for my talk today. So here's some images to leave you with. We now know that Mars was covered in water in its past. It could have hosted life. We found that out with Perseverance and its little helicopter Ingenuity. And with that, I am happy to take any questions you guys have.